want to take this opportunity to really thank the Florida International University, my alma mater, and especially the Cuban Research Institute and Dr. Duane for allowing us to be here. This morning we are having, beginning here on my left, we have Dr. Hector Fuentes, who is a College of Engineering and Computing at FIU, followed by Eduardo Vega with Miami-Dade Water and Sewer Department, and also an active member and director of the Cuban American Association of Civil Engineers. We also have Dr. John Proney from the Applied Research Center at FIU, and Dr. Giorgio Dacier, who is the Applied Research Center at FIU. So the first speaker, Dr. Hector Fuentes. I'm sorry.
Thank you. Thank you for the invitation, and thank you for the opportunity to come and share what I learned over the last 7 days about water in Cuba, water infrastructure. We have probably be better in some of the previous sections. That goes with my academic work, engineering practice. But I accepted the challenge of exploring and taking a perspective of what the future development needs are from my own investigation. Just to share with you, yesterday I was lecturing in a class that is very related to this topic. It's called the Water Resources Engineering class. We teach that class for seniors. And we go over all the aspects of the management of water resources from the engineering perspective. And as I was lecturing, the flash drive was sticking out right here at the bottom. And as I like to move around, I broke the tip of the flash drive, and the 4 prongs came off. And I lost all my work that I have done over the week, learning about the infrastructure in Cuba. Well, the good news is I managed to recall some of the highlights, and those are the ones that I'm going to share with you now. Most probably some of my colleagues in the previous section highlighted some of the things that you can Google about Cuba and find from available information. And I can tell you that I could find information, general information, to put together a perspective of what may be going on in there from the international agencies and also from the national websites within Cuba. But I couldn't find all the information. Details were difficult for me to access. An example of that, just simple records of rainfall patterns and so on and so forth. So I managed to go around and somehow I collected information which I'm not really sure. It does have a QA, QC background, but I can tell you that that is going to be a question on any of the pieces of information that we are sharing here, at least from the water quantity and water quality perspectives. But that's Cuba to me. It is not too far away from us. And it does have a lot of things in common with Florida. And I'll make that point in a few minutes from the water perspective. But it does have some differences. Here in Florida, we are flat. Everything looks like a table, okay? So when the water falls, it moves on the table. So that creates very unique challenges. In Cuba, the relief is different. There are 4 mountainous groups that change the way the water moves, as some of the speakers were referring to. And obviously that creates a tremendous spatial variability over the entire length of the island. Looking with more detail at this map, which I enjoy a lot, you can identify sort of in the yellow the areas which are defining the mountains over the entire length of the islands. And in between what you would have is valleys and plains. Plains on top of aquifers with a very old geology, very unique soils. All of the important ingredients of what the water will do, how long the water will stay within the entire system. I like to work with systems. If you're looking at that picture, that is my system, and it's a system that offers tremendous spatial variability within very short distances. One can identify pretty much 2 general areas of drainage. More rivers right by a divide. They run either south or they run north. So that's a very important feature to think about. Most of the catchment areas do not extend beyond 40 kilometers in length, with about 200 square kilometers in area. So that sort of defines for us the potential catchment of water that is falling on the island. In addition to it, shortest distance across the island, about 30 kilometers, 31 as reported. Longest, about 191. Now, in plains and valleys, as they drain, encounter the coastline, as the interaction between the ocean and the terrestrial water environment is going to be very intimate, as it happens here in Florida. And of course, as we talk about groundwater, if groundwater is extracted and it's not properly managed, then saline intrusion is going to take place. And this is anthropogenic, in addition to what we expect to happen in the entire region, which is the sea level rise as a result of the climate change. With that system, we can identify land uses, and you could probably take a look here on the corner, a lot of mining activities going on in the valleys, agriculture, cattle ranching, and so on and so forth. Of course, all these activities are activities that may be defined as sources of contamination, which in the aspect of water quality, it is extremely crucial. Interesting. You know, we have an area here, right here. Let's see. That is the area where the extremes are fantastic, just like here in terms of precipitation and evaporation. We have the highest records right there, and we also have on this side the driest conditions, and that creates very unique conditions in terms of water management. Of course, there are sensitive resources. This is a really nice map that I could find, which looks at the mangroves and forests. Locations, very important areas where right around the ecotone, where the land meets the ocean, which is a nursery for a lot of marine life, which we have to keep in mind as we go along with the water in this tour. These are some of the records that I could identify. These are for precipitation. July, which is sort of the mid part of the rainy season, which is not far from ours. It's about a month in terms of lag. And in the dry season, the coloration goes with the amount of rainfall that is collected. So you have the contrasted situation in the rainy season, and then we have the dry season here. I was able to go back and look at records, probably 2000 just about. And this is for 2010. This is the same kind of pattern, but you can see how dry the dry season could be, particularly here in the southern part, toward the southeastern part of the country. In summary, we're talking about an annual, and this is, again, this is what I found in reports, and I have to believe that because it is information that comes from some of the national agencies, which, if they report it, all these also go in international records and so on and so forth. Obviously, I'm not comfortable about information that is not provided. The reason why it's not provided is because it's information that cannot be shared. So from that perspective, I will have to take this basic information as the best I could identify. But we can see that the average in terms of precipitation for the whole country, annual, is about 56 inches. Here for us, South Florida, it could be 62, 64, somewhere around there. Most of that coming during the wet season, 80%, dry season, about 20%. Cumulative annual evaporation, quite significant. On average, 1,600. Notice that the range varies between 800 and 2,100 millimeters. So it's a very wide range. So we have here a reality which is very intense spatial variability and very intense time variability, which obviously has to be understood in order to come up with basic strategies to deal with the water. Geology, old rocks that vary in age for the most part in both the mountains and the valleys, and soils, which are very unique types of soils and then are very rich soils, but also with very loose characteristics in areas which are more hillier, and that obviously brings sediment transport, which is one of the things that I could identify. Sediment transport seems to be a major issue in the landscape, particularly through mountains, and I'm referring just to the soils, both in the mountain regions where they are loosely attached, so heavy rain could create a lot of issues, and that also impacts water quality, not just of the surface waters, but also along the coastline. And these issues offer interesting opportunities to look into it in much more detail. One of the things that I did was to try to understand who's who in the business of water there. And based on my own findings and analysis, by all means, this is a lead institute in terms of quantity of water. At the present time, they are implementing a policy that just was outlined, which I do have actually, and I went through the entire details. But there are pretty much 4 guidelines that define what the priorities are, which include very, very important concepts, like the concept of water budget, to ensure efficiency of the use of the water in all aspects. Investments, so there is a clear recognition of the need for hydraulic infrastructure. Incidentally, most of the verbatim or the words used actually use the word hydraulic as opposed to water resources. Hydraulic, and that seems to be embedded in the legislative history that I could identify. That has some interesting implications and aspects for dialogue, at least in my discipline. And then a recognition of the need to rehabilitate the available infrastructure. And this is not just what is available in the cities. It is over the entire cycle of the water on land, from the source after the rain, conveyance, then next to distribution, including the cities. So it goes well beyond just water supply and sewage systems. The target